structure, but SQL, just like other relational databases, there are standard queries where if you just want to say, hey, give me every database that's been created, give me every table that's been created, it's got that too, but you actually don't need it because you don't need to guess the database structure. You just go to the site and you get a copy of it. So in addition to using cross-site scripting as an attack vector, if you have the ability to redirect a browser's traffic, you could also use that as an attack vector. So here's just a simple WebKit. So if you want to see HTML5 relational database capabilities in action, just go to webkit.org. They have this neat little example where you have you make these sticky notes, and you go to the site and then go check those storage locations that I showed you in an earlier slide, and you'll see that it's actually created a relational database. And you can open that up in one of the SQLite viewers, and you can actually see what's there. So, but it has this concept of a same origin policy. So if I go to visit this site, it'll create it specifically for that site. This is just one of those SQLite browsers, SQLite Database browser, free SourceForge project. And you can see that traditional database. I just have the structure. I can execute SQL against it. Oh, this is the storage location. Sorry, in this case, I hadn't shown it to you before. So I only showed it for Mac OS X because really today that's really the only platform where you're going to see this on, because it has to be, well, that's not true because Chrome supports it now. But I didn't actually do this on a Windows machine. But same idea. It will have a standard storage location. So if I wanted to, remember I conducted the SQL injection, client-side SQL injection attack using cross-site scripting for gears. Same thing here. Although this is what I would need to inject. It's actually one step easier because in the gears example, I had to call that outside library. I don't have to do that because now it's actually baked into the browser. This is real functionality that is part of the browser, in this case Safari. Same thing. All I have to do is know what database to open. Don't have to guess that. I just go to the page, get that information, and then just execute my SQL. That simple. So if I could inject that content, I could actually read from the client-side database. So how could I do that? We already talked about the concept of using cross-site scripting to do it, but are there other options? Well, yeah, I could use traffic redirection. So all that matters is my browser must believe that it is going to the site that set up the database, and as long as it believes that, it will freely allow it to query that database. So to demonstrate that in a simple fashion, so here I go to the site where this demonstration application is, webkit.org. Make a couple test notes there. And you'll see, that's the URL where it is stored online. All of this is client-side, so I can just copy, literally view source code, grab that source code, set it up on my own browser, and then now you can see, it's the same page running on localhost. But those past notes didn't come up because my browser says, oh, I'm not going to, this isn't the webkit.org database. I got to create a brand new database for localhost. So it had a fresh template. So I created a note there, just say, hey, this was written on localhost. But then, just to show a redirection, I just changed my etc host so that webkit.org will actually get redirected to my local machine. And now when I view the page, sure enough, I'm seeing the original notes that I'd set up that were at webkit.org. So if I could redirect traffic, as long as my browser believes that it's going to the site that originally created the database, and I have the ability to inject JavaScript into that page, now I can query that same database. So I wouldn't necessarily need cross-site scripting as the attack vector. So maybe I do traffic redirection through some kind of DNS hijacking, or I have a browser vulnerability where I actually have the ability to write to the file system, so I just physically alter their etc host file. I definitely see a proxy as a capability to do this. You convince somebody to view the web through a proxy that you're running. You can just inject the JavaScript directly into the stream and conduct your attack that way. Or as I'd mentioned, cross-site scripting. So what kind of stuff is stored in there? Well, a lot of Google applications are enabled to do this. And if you want to see it in action, obviously it's kind of hard to test on your phone. Because the desktop version of Google Voice, for example, won't use the HTML5 relational database because they already have gears running for that. But a simple way to test this is just change your user agent. You're on Safari, change your user agent to the iPhone user agent, because that's how it decides what website it's going to deliver up. And then you'll get the iPhone page, and it will actually create the relational database and use the HTML5. So just to show you, these aren't simple databases. There's a lot of stuff stored in there. Here's a view of Google Voice. Here's a view of Gmail. This is all the stuff stored. What is actually in there? All kinds of stuff. If you look at the Gmail relational database, it'll have snippets of all of the emails. It won't have full email messages for everything. It does, however, have full message body for cached messages. So I don't know if there's a number limitation, but there's usually a couple dozen messages that actually have the full message in there. But it'll have email addresses of who the email was sent from and to. So in my opinion, really valuable information if you're an attacker that you could retrieve this. Google Voice, really interesting as well. Because it doesn't store the voice messages, so you're not going to be able to steal those that way. But you can definitely get contact information, name, phone numbers of people, addresses, and even their image. Like if somebody's added their image to their Google account, I thought that one was kind of interesting. It'll store the URL for it, and I'd assume that that would be locked down based on, you had to be logged in. So if I stole that URL, no. So you could actually even get pictures of all the people that somebody was friends with. So, but why is this different? If I could get in line, I could already sniff your email. As I'm sure that this weekend many people have had their email sniffed, right? Because they were using an open network. So why is this different? Well, the difference is that this isn't passive. This is active. I don't have to wait for the information that I care about. I can actually query the database. As long as I can get that client-side JavaScript in there, I can write whatever query I want. I can say, give me the whole database. I can say, show me all the person's friends. I can say, show me all the phone numbers of people. So this is actually active querying of the client-side database. And this is functionality. It's not exploitability. When a traditional SQL injection attack, I have to find something that's vulnerable. So I couldn't do that on any site. In this case, if I can inject my JavaScript, it's a functionality. I can query the client-side database. Gears versus HTML5, again, these are not competing technologies. Expect Gears to actually fade away as HTML5 becomes more available. Today, the relational database component of HTML5 is really only available to WebKit-based browsers. So that's primarily Safari and Chrome. It's not supported on, I think I actually have, maybe I showed it earlier, but it's not supported on IE, it's not supported on Firefox, not supported on Opera. But once those browsers support this relational database local storage component of HTML5, then I think you'll see Gears disappear once and for all. Just to compare all those different storage technologies, cookies, hey, we've had them forever. The beauty of them is that they're universal, so if we want to use that as a storage mechanism, everyone has them. Real limited though, 4K of data typically. I can only store text in there. Flash local shared objects, just to review that. It is pretty much universal, thanks to YouTube. Everybody runs Flash. And I have greater storage capabilities, 100K by default, and people typically aren't going to be able to flush that. But the future really lies not so much with Gears, but HTML5, although they're pretty much the same thing from this perspective. Unlimited storage. I mean, there's no restriction on how much you can store there. But it's the adoption that's the big difference. There aren't too many sites and end users that are using this just yet. So how will this change things for an attacker? Well, now we're dealing with active attacks. Again, this isn't passive data sniffing. If I can get my JavaScript in there, either from cross-site scripting or from injecting it through traffic redirection or because you're running through my proxy, I can query that relational database on the client side. The structure is open. I don't have to guess at what the database structure is. Easy to find out. So the attack surface is very different. Before, we had all the data stored on a server somewhere. Everybody's data was there. If it was vulnerable, really bad, because I could get everybody's data. Now I have everybody's data distributed all over the place. So I'm only going to get their data, but in my opinion, actually a lot easier to attack, because all I have to do is get my JavaScript in there, and there's a lot of avenues to do that. And just the cross-site scripting angle alone, If 66% of sites have cross-site scripting vulnerabilities somewhere on them, and again,